Hello and welcome to this lecture. So in the previous lecture we just worked with this some of the key binding actions, and that were in order to handle this jump action and similarly for this walking action. So let's go now for this left and right action. So let's check now for this key, and this should be inside this tool and key bindings, and that should be for now. Let me just check here for the left. And what you're gonna do, if the key binding is basically left, then we'll say just get me out of this crouching from this function. And also what you're gonna do next is we'll say because this is basically for the left, so we'll just say that is the facing right. So here the facing right should be false obviously, and we'll just check for the velocity in the x now. So we'll say self dot x velocity is, if it is greater than O, then just assign the frame index, so that should be frame index to somewhere to 5 to 6, and similarly self dot x acceleration. Now self dot x, this acceleration now should be c is small, and we have now something that is turnaround here. So there should be a small turnaround when this is velocity greater than 0 in x. So similarly, what if we don't have that velocity greater than 0? Then we should have just this minimum acceleration, so that should be made as here the walk acceleration. So that should be x acceleration should be made as c dot walk acceleration. So this is the case basically when the velocity in the x should be less than 0. So the next thing what you're going to do is we'll just check now again for this velocity, but in this case we'll just check for this velocity with this maximum x velocity. So we'll say if the velocity, that is the current velocity, and x velocity, that should be velocity, is greater than, and we'll say self dot max velocity here, max x velocity, and just multiply it by -1, that is in the right direction. Now if it is the case, then we'll just assign this velocity now, and it is really interesting because we are just assigning this velocity to be the negative of something that is just decreases every time with this acceleration. So this is the code basically for the softening of our speed. So next thing what you can do is you'll also check if the velocity that is in the x. So if the velocity in the x is greater than -0.5, so that means what you're gonna do is we'll just set this velocity to be, now again we should smoothen here by assigning it to be -0.5. So let me put a colon here. So after that what we can do here is, so let me make a space here. So first we'll check again for this velocity, and basically if this velocity will be again, that is the negative of max of velocity in y direction, basically in maybe not in y, it is in right direction, then we'll just increase that velocity again with this acceleration. So previously we just decreased that with acceleration. Now just let that copy this all of its code. Let me just copy it and just paste it in this else part. That should be like, let me say it should be elif not else. So let me just paste it here saying that, let me just go back here and just put it down here. So let me just make an indent correct here. So let me just cut it and paste it here. So this is the case, but instead of just subtracting, now we have to add here. So the next thing what you can do is we'll check for the left. We have already covered for the left, so it's time to check for the right now. So So just go deep down here and paste it, and instead of left we have right here. So let's check for the right. So firstly, same as that of left, we have to just get out of the cross from this function, and we'll say facing this right should be here true. In the case of the left it was false, now it will be true because we are facing to right here. And now it's time to check for the velocity, that is if the velocity is basically is greater or less than, firstly we'll just check for the less than 0, and you have to make this as the frame index equal to 5, and just let me just copy it and paste it here, and here the frame index should be 5 and the acceleration should be a small turnaround here. And that was the case if it was greater than 0 because we were basically moving in the left, but in the case of right that should be basically less than 0. The velocity, if the less than 0, there should be the small turn around in the acceleration. So after that what we're gonna check is, we'll just in this else part, so let me say else, if the velocity is greater than 0, then what it should be is, we'll just assign the acceleration to the walk acceleration, that is self.acceleration, that should be in the x, and all these acceleration, because this is 2D game and we won't be moving upward, so all the acceleration and velocity will be only this x. So we'll just count or just make this account, that is the x component of the vector or basically acceleration, and that is velocity. So let me say if self.x acceleration, that is the acceleration, should be now assigned as in walk speed here, that is walk acceleration speed. So let me go back here and just put here walk acceleration. So next thing what you can do here is, well, again check basically for that self.x velocity, and if it is less than maximum velocity, self.max x velocity, then this x component of velocity should be added. So in the case of the left, there was this velocity greater than that max position velocity, but in this case we'll just add this x component of velocity with this acceleration, that should be x acceleration. And the next thing what you can do after this is, we'll just check again, that is the x velocity is less than 0.5, and if it is the case, then you can just assign this x velocity to be 0.5. So this is the condition basically in order to check this x component of velocity is moving within speed that is near to 0.5, or basically within maximum level speed, that is basically closer to this maximum level speed, then just assign this x velocity to be smoothing to nearly, that is 0.5, or you can assign 0.5 here. So after that what you can do is, we'll just go back here and we'll also now check, that is if this velocity, we have checked if it is less than max level, but we'll just check if the self, that is the same current velocity of x component velocity is now greater. So if it is greater than the max velocity, max x level velocity, we should smoothen this velocity. So in order to smoothen, we have to just decrease that velocity by a constant acceleration, that is x acceleration. So after that we'll just say here that we'll just check if it is facing right or not. So that should be if self, that is basically if our Mario is facing right, then we'll just check the velocity again, that is the x velocity, and if the x velocity is greater than 0, So just smoothen this velocity gain by basically this smoothing should be done from this acceleration. That should be self.x acceleration. That should be the x component. And after that, what we can do is we'll just check for the else part first. We'll say if it is that case, so what you're gonna do if it is velocity that is less than 0, then we'll just make this velocity that is now 0 first. That should be 0. That means there should be no movement at all. And after that, we'll just constantly add. So before that, so this is velocity 0 means we just make our Mario to stand. So that should be that state. So the current state now should be c dot stand. So our Mario should be stand now in the stand position when the velocity is 0 at the x component. After that, if it is not facing right position, what are you gonna do? So here too we'll just check now. Again, if the velocity at this x is, if the velocity at x is, if this less than 0, then the smoothen should be done in the x velocity, and that should be from this acceleration, that is x component acceleration. And similarly, if it is greater than 0, that means we have to make our Mario still, because it is not facing right and we are dealing with this key binding, right? So if it is not facing right and if the key binding is right and if the velocity is greater than 0, that means you have to make this velocity that should be equal to 0 and just make our Mario just to stand here. So don't make our Mario to just move in any way. So just make that see that stand. So we have just finished our this main function, which is basically walking, and this was very long function and we covered it in the 2 lectures. And in the next lecture we'll just calculate the animation speed and bunch of that functions. Basically we have some functions here to make, that is get out of crouch has been made. We have to make this falling, jumping and jumping to death, and this bunch of functions will be covered in the upcoming lectures. See you there.